Welcome to the Building Performance Podcast, which we do rarely these days, but today's a good excuse for it. Where we're going to talk about building performance, home performance, the science of homes, physics, chemistry, microbiology. We're going to tune in specifically on HVAC today because we got Russ King, who is a friend of mine who has been building HVAC design softwares with his son Connor. Russ, thank you very much for coming to the show today.
My pleasure. Always great to talk to you.
Yeah, likewise. So you have some really interesting knowledge of the back end of how these softwares get made and like what actually they're doing, which I want to pick your brain about. We're not going to try and get too much into the weeds in this. So if you're watching this for the first time, and you're like a normal layperson, this is going to be a great time because actually Russ has a software that is now enabling normal people to do their load calculations. Is that right?
Yes, we facilitate and we assist homeowners to do their own load calculations. Yes.
Great. And I think that's very useful because until we've got all the professionals in the field able to do load calcs and interested in doing load calcs, like somebody's got to do it, right? And by the way, would you touch on like why specifically? People have probably heard it from me, but I want them to hear it from you.
You mean why it's important to do load calcs or why contractors are not doing it? That's a long discussion. Yeah. So you you have to measure your house. If you're not measuring, you're guessing. And the size of the equipment that goes on your house needs to be sized appropriately to the load of the house. So you think of it as supply and demand. So the demand is what the house needs, and the supply is what the equipment gives you. And so you have to calculate that demand so you can pick the appropriate supply. And everyone's worried about undersizing, about your supply not being enough, and your heating and cooling system not keeping up on extreme days. That's what everybody worries about. But it's actually worse to oversize your equipment and make your equipment way too big. It results in a lot more comfort complaints. I get asked all the time, and not as much as I used to, but I've gone out and diagnosed hundreds of homes that where the homeowner wasn't happy, but the contractor says we installed it exactly like the plan. The equipment is working properly, but the homeowner's not happy. I've done hundreds of those, and 95% of those homes, the problem was that the equipment was too big for the house. It was oversized based on that house's load, and that caused all kinds of problems. And then of those, I would say 90% of those had undersized ducts. And when you oversize equipment and undersized ducts, that is a really bad combination. But the problem is people immediately think, oh, my equipment's undersized. That's why I'm having these problems. And it's not, it's the opposite. So there is too big and there is too small. And so HVAC sizing in Manual S is kind of an art of matching that load to the capacity of the equipment.
And we'll get into that a little bit more in just a minute. So what's the name before we move on? What's the name of your DIY
It's
software solution?
Yeah, it's actually a website. It's DIYLoadCalcs.com. And
Great.
that walks them through the process. There's a detailed instructions. And then we use our software. Our software is called Kwik Model 3D. We use that software to actually do the load calculations, but there's a whole process of data collection and all that other stuff that we walk them through.
Awesome. Let's get controversial right away. I ran the blower door test. I ran the manual J on my parents' cabin, which is a 1960 single-story ranch over a crawl space that we have encapsulated. And it said that we need 2.5 tons of cooling, but 65,000, so 30,000 BTUs of cooling, 65,000 BTUs of heating. And we had 3 design days in a row. In a recent video where we detailed the install, I got to kind of go over this. And it actually doesn't need heat strips at all. It can do perfectly well on a design day with 30,000 BTUs of heating, not 65,000. What in the world?
So Manual J is a tool, right? It's a tool. And think of it as a tape measure that's got really weird numbers on it, and you're not quite exactly sure what it means. And so you go out and you measure it. If you measure a board with a weird tape measure, and your board comes out long, can you blame that on the tape measure? Well, yeah, technically you can, but if you know that tape measure is long, can you adjust for that? Can you compensate for that? And yes, you can. The more you understand that tape measure, the more you can compensate for its assumptions that it makes, which are, if you're going to write a book about how to calculate load, you're going to play it safe. You're going to, your assumptions are going to be kind of worst case assumptions. But as long as you let people know that and you allow them to compensate for that, they can bring it back down to where it's supposed to be. And if you look at, what is Manual J really asking for? there's a ton of stuff it's asking for. So you got the geometry of the house. That's the actual shape, the wall areas, the window areas, the floor areas, and that's all on the user, right? They're the ones who measure that. They're the one who inputs that number. That's not a guess. That's an actual number, right? And then after that, you've got the performance factors. What's the R value of the walls? Actually, U factor. What's the U factor of the walls? What's the U factor of the ceiling? Those are all estimated by the user, not the software. Those are estimated by the user. So that's all on the user. And then you've got your temperatures, right? You've got your indoor temperature. Those are set by code typically. And in California, they're set by code. We have to use, so most of the country uses 70 degrees for winter and 75 for summer. Okay. You're not supposed to mess with those. And then you got your outdoor temperatures. That's probably the most controversial. Well, I wouldn't say controversial. That's probably the most squishy thing. That's the hardest thing to really pin down. And and those are set from tables. You look up your city and you find those numbers and you plug those in. Your indoor temperatures and your outdoor temperatures set a delta T. And that delta T is used to calculate all the heat transfer, not all of them, but a lot of the heat transfers, all the conduction and all the convection. Doesn't have anything to do with solar gains, but and so the question is, what do those numbers really mean? Probably the most common tweak that I see contractors make to load calculations is bumping up the outdoor summer temperature, right? They'll look up their city and they'll say, oh, it's 95. Heck, it hits 105 here all the time. I'm going to use 100. That happens all the time. Sometimes it's even worse. Sometimes they'll actually look up what's the highest temperature on record and they'll use that, you know. But what you have to realize is don't think of that as a real temperature. Think of that as a point in a flux. Okay. So imagine sitting in your house and it's 80 degrees outside and you're sitting in your house doing your work. You have no idea what's going on outside. What if it suddenly outside went to 100 degrees outside and stayed there for 20 minutes and then came back down to 80 degrees without you knowing it? Would you ever sense that inside your house? Probably not. Your house would probably stay comfortable that whole time. Your AC might kick on once, just to compensate for that. But the point is that everyone thinks of that delta T or that outdoor temperature as a steady state temperature, that it's been at that
Like a
temperature for a
still
long.
photograph of like,
Exactly. Like that it's been at that temperature for a long, long time. Well, it's not. The temperature, if you look at a graph, the temperature goes up and down, and it's just a point where the temperature is passing that point. And so, and also when they say, oh, it hit 105 last week, how long was it 105? Just a few minutes, right? That was the tip of the spike of that day. And so that's one thing I think a lot of people have to realize is what do those temperatures really mean? Manual J always plays it safe on that. And then what are the other things that go into Manual J? You've got infiltration, and Manual J has its defaults, and those are wags, right? Those are wild ass guesses. We have no idea. They give a description of what the ceiling and stuff like that is.
I do
And
have a video on what those defaults mean, like what they translate
yes,
in a general sense. But yeah,
yes,
they're
and
pretty weird.
even if you followed that description exactly, you could still be wildly up or down, if you actually measured it. And then so let's say you did a blower door test on your house, right? So we consider that measuring the infiltration. Even that's not accurate in real life, right? When you pressurize a house and you measure how much air is escaping at a certain pressure, that does not exactly correlate to what the actual infiltration is going to be on a given day, right?
Well, and
Because you've
so
got
let me
stack effect
pause
and
you
all that
right
other
there
stuff.
because this is something that I find really interesting. I use Elite Soft historically. I'm very interested in Kwik model too, but I have historically used Elite and Right Soft, which are the two kind of like original softwares that are used by residential guys.
They're the OG. Yep.
Yeah, if I use Elite, which is what I always used, and I change the blower door test from, and I'm going to be nerdy for a second, from like 1 ACH 50 to 2 ACH 50, twice as leaky. Elite is like, I don't care about any of these numbers. It's zero. It rounds it down to zero. I think that that's probably realistic. I think RightSoft overestimates how much air leakage is actually going to impact. And I've seen that happens a lot. EliteSoft might be underestimating, RightSoft might be overestimating. Are they doing the same actual calculations behind the software as like REM rate or a HERS rater software is going to do? do you think? Or are they
Yeah,
building in
actually,
some extra bumper behind the scenes also?
well, they're obviously doing something different between those two load calculations. And to be perfectly honest, I don't know exactly what Manual J says about how to take a blower door number, a CFM 50 number or whatever, and convert that to an ACH, or how to take an ACH 50 number and convert that to an ACH. All I can tell you is that the algorithm that we use comes from the Florida Solar Energy Center, the folks that write Energy Gauge software, and they've done thousands of tests on that, to figure out what that is. What
And
the
that's why
actual
you
algorithm?
guys, that's a HERS rater software, like an energy modeling software, which I think is more on the purest. They know how blower doors work. I've been
Exactly.
told that like the people who write the other two softwares that we were talking about have maybe never run a blower door, or their idea of what a blower door should be isn't what anybody else's idea should be.
Right, right. Yeah. And so that's a great question. I mean, I've got Manual J right here, and I honestly can't tell you. It's been a while if there's actually like a formula in Manual J that says take this number, do this to it, and then it results in this number, and then plug that into Manual J, or that's what the actual calculations are based on. I honestly don't know that. I've just kind of trusted Energy Gauge. They
Mm.
got certified for Manual J and everything, and we use their load calculation engine. Um, but the point I'm trying to make is even the actual measurement, you could measure two houses and get the exact same blower door test. And when you take that blower door off and you let them do what they have to do, they could have very different infiltrations affecting the loads between those two houses. So even the blower door test is not perfect.
Because of the shape and where the holes are. Is that what you're saying?
Yes, exactly. Where the holes are up higher, the holes are down low, or they're evenly split, all that kind of stuff. And is it a two-story house? Is it a one-story house? And how much wind is hitting it and all that other stuff. It's the best test we have, but it's not perfect by a long shot. And Steve Rogers at the Energy Conservatory can go off on that. I mean, he can tell you, he can talk for hours about why it's not perfect, but it's the best test we got. And as far as measuring quality of construction, it's great. If you say you have to meet this certain blower door test when you build this house, they have to do a decent job sealing it. It's just that, like I said, two houses with the same test might end up having slightly different, or even, I don't know how drastically different. Um, but then the other test is duct leakage, right? Did your parents' cabin have ducts in it? Is it,
Yes, but they're
it's
all
this,
inside the conditioned space.
no, okay, that helps a lot. That certainly helps a lot. Um, the other number that goes into Manual J would be internal gains. So on the heating side, Manual J goes, nope. That helps the heater, so we're going to say no. We're going to assume worst case. But what's the chance? So when your parents' house hit those 3 design days, were they even home? Was there anything turned on inside the house?
They
And if
weren't.
they
Yeah,
weren't,
it was
okay,
like
okay,
it
interesting.
was bare bones, perfect
That's
manual J, like simulation.
Got it. That's data. That's good data. It's interesting now that you mention it. There's 3 homes in Stockton, California, that PG&E bought back during the recession when they were dirt cheap. They bought these 3 homes in Stockton, and they're empty, and but they're constantly monitoring them, and each house has like 3 systems in it, and they can alternate between the different systems, so they have mini splits and gas furnace and heat pumps, all this other stuff. But they simulate people with little humidifiers. They have little humidifiers that are on a timer to simulate people being in there, and then they have little electric heaters that turn on and off during the day to simulate people, and they're monitoring. That's a really fascinating program to see. And I don't know if they've done any Manual J comparisons or anything to see
Hmm.
how that goes. So okay, that's good. So the duct leakage is easy. Internal gains, there was nobody there. The other big one that a lot of people say Manual J sort of under quantifies is thermal mass,
Right.
right? Thermal mass. Again, Manual J sort of assumes steady state, which takes thermal mass out of the equation. But you said a log cabin. Is it an actual true log cabin?
So no, it's not. It's
Oh,
a
okay.
ranch that's 2x4s, but it's got brick cladding around
Uh,
the whole thing. It's got cinder block foundation. So and that was where like I think that my problem here, just to cut to the chase for the audience, is that there are codes, and I don't know if they have this in California, where you have to provide like something like 80% of the manual J heat requirement as emergency backup.
oh, okay. Interesting.
And if manual J is already overestimating, and then I have to buy heat strips that are like enough to provide 80% of what I thought it was, then that's just crazy. And so the idea being when we're talking about furnaces, it's a lot easier because you could just have as much heat as you want. But if you're trying to go to a heat pumps are generally, if it's 30 of cooling, it'll be about 30 of heating. And I think that that's more realistic for this house. It actually can do 30 of both. And it's not even a high performance house. So that's where I think that it's kind of punishing the heat pumps. And I wonder, there's always backstory on the politics of all this stuff. But it's since the heat pumps are kind of new to the game, I wonder if they're being punished for old fashioned reasons.
Yeah, definitely, definitely. Yeah, and the whole, there's a difference between emergency heat and supplementary heat. Emergency heat can only come on intentionally with a manual trip. You have to turn it on intentionally, whereas supplemental heat kind of comes on automatically if it feels like the system's not kicking on and stuff like that. But yeah, it's really interesting in California. We've been, 99% gas furnaces for the last 10 or 12 years. And now we're going to heat pumps, and we're starting to really look at the heating load on a house. And what's fascinating to me is how much heating load comes from a slab on grade floor.
Mm.
Check it out. It's incredible. It's like
It's like
almost a
half.
third. Yeah, it's
Yeah,
at least, yeah, almost a third in California. Almost a third of the heating load is through the slab. And I'm like, why don't they require slab edge insulation in the energy code if it makes such a big difference? Well, the energy code is based on annual energy use and cost effectiveness, and they claim that it's not worth the cost. But then when you look at the load and how much effect it has on the load, and it could actually have you put in a smaller heat pump if you do insulate your slab. I think we're going to start seeing more slab edge insulation go in California. I really am. Um, so, but yeah, so thermal mass I think is probably one of the things that Manual J probably doesn't do as good of a job as it could. I don't know if you remember way back in the passive solar days when it first started come out. When I first started doing energy modeling in 1988, the big thing was passive solar, and it was having, you know, optimal overhangs and all this other stuff. And they had something called trom walls, which was basically a 2 foot thick concrete wall running down the center of your house, and it was just thermal mass. Well, I don't think Manual J would even take that into account if you had something like that. If you had, I remember my boss Marshall Hunt had in his house, he took culvert pipes, like 2 foot diameter culvert pipes, and they were like 12 feet tall, and he sealed them, and he filled them with water, and he painted them black, and they were on the side of his house that in the wintertime they got direct sunlight so they would warm up, and then he could close those blinds, and then these metal pipes full of water would radiate heat and heat his house all night. I don't think Manual J even takes something like that into consideration.
sure.
But that's a time dependent thing. That's not a instantaneous. And Manual J is an instantaneous sort of load calculation.
And I
So
think that's where it's weird is that like, it encourages that snapshot, that still photograph image of the house. The one other thing that I just want to point out here is that like furniture, depending on how full the house is of furniture and what kind of furniture you've got, if you've got all concrete furniture in your house, that's also thermal mass. And like,
yes.
so anyway, just like these things are running through my head as I'm doing this. Do you have any other thoughts about this oversizing of the heating side?
Well, I just think you can adjust your loads. If you just take Manual J as like whatever defaults come in the software, you're going to be way oversized. But you have the ability to go in and shave things down. You have the ability to adjust your U factors. You mentioned furniture. Here's an interesting one. Let's say you've got an R11 wall, and you slide a great big leather couch up against that wall. Have you changed the U factor of that wall?
Hmm,
I think you have. I think you've greatly reduced the amount of heat that's going to come through, at least that where the couch is. That doesn't, no one thinks to take that into consideration too. Or cabinets. If you have cabinets on an exterior wall, that'll slow heat transfer through, but no one takes those into account. So I think, you can shave your U factors or actually raise your U factors to adjust for things like that. There's a lot of places where you can tweak things, you can take things into consideration and get your loads down to where they're not so grossly oversized because you're just assuming the default settings in the software.
awesome.
One of the things you can't do, and that's what I was kind of getting at, one of the things you can't do is really play with the thermal mass part of it. But most everything else you can, everything else you can tweak. And then there's the one thing, and not an issue with your parents' cabin because they weren't there. Homeowner behavior. How the heck do we take that into account, right? And I like to use the example: if you had 100 identical houses pointing the same direction, right next to each other, all lined up on a street, and they all had exactly the same size equipment, how how different do you think their energy bills would be? You know, and I think they could be 20 or 30% variation in their energy bills just for heating, excuse me, just for heating and cooling, not even lighting and stuff like that. Because one house could have one person living in it, one house could have 8 people living in it. One person, they have no idea how to use their thermostat. You know, they turn it off during the day and turn it back on. So thermostat operation and all those other things come into play as well. So, you know, the writer of Manual J, Hank himself, had to sort of take those things into consideration and say, well, I've got to guess worst case, you know, otherwise, or not very, very worst case, but on leaning towards worst case. And so
Hank is
all
great,
those,
by the way. For those of you who are listening, there is an interview on this podcast with Hank Rutkowski, and he's basically like an engineer pirate. If you take those two people and you put them together, so like you should listen. It's one of my longest interviews
yes,
ever.
I was Hank's handler for a few days when he came out to California. I had to pick him up at the airport and check him into his hotel and everything. He's an interesting character.
Yeah, he is. Okay, so let's leave the cabin for a minute because that's an older house. Now we've got newer houses, and I've got like, for example, I have plenty of clients who are building super airtight, very well insulated. They're inspecting to make sure the insulation is put in the right way. Once you start doing some pretty good stuff and you're doing everything pretty well, I find that the performance of it is going to be much different, especially once you take that ERV and you run that in the house. So aside from the tips that I give on my channel all the time, what are you advising people to do when they're designing for that kind of a house?
Well, the main thing is you're working from a theoretical house when it's if the house is not built yet, right? It's a theoretical house. You're hoping it's going to get built the way you assume that it is. And so going out in the field and actually testing the house and commissioning it is really important. You know, most of my career I designed for large builder production homes. The you know all the biggest builders, Lennar, Taylor Woodrow, KB, Centex, all the big builders. We did all the California and Nevada divisions. We designed for those, and you know, I had my plan and I designed my plan. We made certain assumptions about the house, and for example, I remember when Lowy windows first came out, or not first came out, but first started going into production homes. Um, the Lowy window manufacturers couldn't keep up, and so for some strange reason, a bunch of clear windows got tossed in the truck so they could, you know, so they could leave the dock, and they would show up on site, you know, and then we'd get a call from a house in Las Vegas, and they go, oh, and it was always the baby's room for some reason. Our baby's room is not, yeah, our babies are not cooling down. You're the mechanical engineer. You need to get your butt out here and figure out why it's not cooling down. And we'd go out there and we had a design. We knew how much airflow was supposed to come out of everything. We would check the size of the equipment, the duct layout, the you know the airflow. We'd measure all the airflow, and everything was great. But yeah, this room is not comfortable. You can tell. Well, we had this little thing that looked like a stud finder, and you go up, you put it on a window, you press the button, and it would tell you if it was a lowy window or not. And boom, clear window. Oh, right there. That's like, you know, that's like 30% more load in that room because that's not a lowy window. And so there you go. Certainly not the mechanical engineer's fault. It's the builder's fault for putting in the wrong window. So those kinds of things, yeah, those kinds of things become much more important. The more efficient a house gets, the more impact one or two features is going to have on the total load. And so even one window in one room can be noticeable.
And I
Um,
think this is one of the interesting things that we're definitely trying to tackle with this channel, with the home diagnosis television series, is like training individual homeowners. Because, for example, in Manual J, like if that they have the ability to control the load to some extent with drapes and curtains and stuff like that, right? Or shutters, um, built trees outside, things like that. And if they don't know how to use blinds or at certain times of day, then they can take a design that's good and then make it not work by not doing things that would be like commonsensical for homeowners from 50 years ago would understand that stuff. But now we're so automatic about everything. Like what solution do you find aside from just educating people back up to that level? What can we do about it?
Yeah, that's a really tough one. You know, I was the one time I was asked to be an expert witness on a defect litigation lawsuit. I was on the side of the builder, as one of our big clients, and the homeowners in a subdivision were suing the builder, and I had to go in and talk to the homeowners, and so I was the enemy, right? I was the bad guy, and but I'm trying to nicely talk to people and say, well, you know, on a really hot summer day and the sun is beating in the your sliding glass door, you really should close your drapes. And you're like, oh no, we like our drapes open. We want to have our drapes open. And it's like, well, you're just making the problem worse. You have to use some common sense. And it's really hard to convince people that they need to behave a certain way in order for their HVAC system to work. They just think that it should just work, no matter how badly they behave, that it should work. And it's an expectation issue. And I think the only way to really just pure education isn't going to work, but you got to get a lot of homeowners in the same room and have them agree with each other and reinforce the positive thing that we want, the message that we want to get across, which is, oh yeah, if you put a homeowner in who's really obnoxious and you put them in with 10 other homeowners who know how to use their system, then there will be some change in attitude, I think. And I don't have any suggestions on how to accomplish that.
HVAC peer pressure. I like it.
Exactly. Yeah, we need some HVAC echo chambers to drop
Right.
homeowners into.
Well, and so keep on listening, everybody. So let's talk about duct design for a minute. This is one of the cool things about Kwik Model, your software, is that it's like a visual 3D model environment. So duct design is, I like to warn my clients that, like, hey man, this is just a piece of paper that I'm going to give you. It actually has to go in exactly like this or else. And so how much of that or else do you think is necessary? Because we've got a lot of people who are like, oh, I actually heard for the first time that Little Rock, Arkansas has outlawed flex duct. They do not allow it to be used. And I thought, like, wow, that's actually pretty impressive. Sounds weird, but like, okay. So if somebody's going to use ductboard, or if they're going to use flex duct, or whatever, or if they're going to make it take more turns than you thought, because of course the framing doesn't always line up the way you thought it was, how much of duct design is like that same, we built the fat into it and you're fine, and how much of it should we worry about?
It's in my opinion, it's even more so the manual J. The fat is built into it, but I think that's a good thing. I think on ducts, Ed Janowak has mentioned and took a lot of flack for it, that ducts cannot be too big. And so oversizing ducts is always going to be safe to a point, of course. And then I took a Kwik Model house and made all the ducts in the house 48-inch diameters. And then I sent him that drawing. I go, here's your house. Here's your house, Ed. And it looked really funny. It was like all the ducts are all swollen. They were like
There's sewer
gigantic.
pipes again.
Yeah,
Just
yeah, exactly. Yeah, big culvert pipe ducts. But yeah, so one thing is, you've only got so many duct sizes, and in Manual D, if you need an airflow that's too big for one, like 5 CFM too big for one duct, it puts you in the next size duct. And if you look at a table, it's amazing. At a certain friction rate, the airflow of a 6-inch duct to go to one size up, which is a 7-inch duct in some places, not everyone sells odd size ducts, but just going from a 6-inch to a 7-inch is a 50% increase in airflow.
Mm.
That's huge. That's gigantic. And Manual D, well, if you're 5 CFM short, it'll put you into that next size duct up. So you've got all this extra capacity, which is a good thing. It's much easier to damper airflow down than it is there's no such thing as dampering airflow up, right? You can't damper airflow up and increase it. So yeah, it's all built into Manual D, and I think that's a good thing. The problem is that people have not used Manual D, and they've just used rules of thumbs, and they go, oh, it's a bedroom, it gets a 6. Oh, it's a living room, it gets an 8. And they just throw stuff out, but they don't take into account, they never stop and add up all their ducts to see if it will handle all of the airflow. They'll say, oh, I might be getting enough air here, I might be getting enough air there, but is the entire system handling all of the airflow of the system? And if you don't, what happens is the static pressure backs up. And static pressure is a very easy thing to measure across the air handler. I hear people measuring 1.8 inches of water column across a furnace and stuff like that. Well, the chart of a furnace only goes up to 0.8. So if you're over 0.8, you're literally off the charts if you're higher than 0.8. And so when the airflow pressure backs up, the airflow drops off the chart. And then when the airflow across the coil drops, you lose capacity and you lose efficiency. So any increase is, you just want to go the other direction. In Manual J, oversizing equipment is bad, but in Manual D, oversizing ducts to a point is you can always damper it down. The only problem with oversizing ducts is you increase surface area, and so there's a slight increase in conduction if your ducts are in the attic or the crawl space. But if they're in conditioned space, it has no impact whatsoever.
And so I want to talk about terminations in a minute, but one note quickly is that I've found that HVAC professionals they're really thinking about two different things, but they think it's one thing often, which is I need to get more airflow, which is conditioning into these rooms. In real life, it's conditioning. So if they see a big room like the one I'm in right now, which is 24 by 36 with 13-foot ceiling height, and they'll say, we need more ducts in here.
Mhm.
And to me, that sounds like, whoa, you're adding more cooling or more heating. Why? But in their mind, they're like, I need more airflow, which is why I'm always pushing our audience to like think about ceiling fans as a part of the HVAC system. And so just know that that happens if you're watching this and you're like, why are we adding more vents into this room that's big? It happens all the time. Do you agree, Russ? Do you have anything to add about
Absolutely. In fact, I can't tell you how many times I've heard a contractor say, "Oh, this room's not comfortable because it has vaulted ceilings." And it's like a vaulted ceiling is going to create all this heat coming in. Well, if you think about it, all a vaulted ceiling does is when you raise the ceiling up, it creates a little triangle. That's the only extra load and maybe a slight little wedge of ceiling insulation. Vaulting a ceiling of a room has very, very little impact on the actual load of the house. And then what you were getting at is it's not the size of the room that matters, it's the load of the room. And the load is not determined by the square footage, it's determined by the exterior surface area and mostly the windows. I've seen giant rooms that need a 6-inch duct, and I've seen little tiny rooms that need an 8-inch duct. And it's because of the load of the room, and it's the airflow is proportional to the load of the room. But yeah, they just say, oh, it's a big room, it needs, let's put a big duct in here, but it may have a tiny load. So,
it?
you got to, that's room by room load counts. You got to do room by room load counts to know that.
So speaking of what you can get at the supply house, and this is a problem because like if you end up doing special orders, for those of you who have not installed a duct system, you're going to run out of stuff, and then you're going to need to go back right now and drive 15 minutes. And if they don't have it, then your entire day gets shot. So it's like you need to buy things that are in stock, and unfortunately, these people don't stock things like for example, a 2x6 grill. And often I'm coming up with like I've just got to take it out of the defaults in my software, but like it'll say you need a 2x6 register on this, and the guys will be like, I don't have that. Um, so so my question is, when we're doing the sizing and the manual J software goes into manual D mode, I'm doing the duct design, and it says you can do this with a 4x6 register or a 4x10 or whatever. Is that manual T? Is that what it's doing, or is it like because so I just want to make sure that I understand. Is that actually manual T at that point?
The only part that manual D takes into consideration of the supply registers is when you're calculating your friction rate, you've got those miscellaneous pressure drops, and one of those items is supply registers, and the default number is always 0.03. I don't know if you remember that, 0.03, and then the same thing for return grills. When you type in 0.03, what you're saying is I'm going to pick a register that has a pressure drop of no more than 0.03. So then manual T comes and says, look at the OEM specs for that register. And there's gonna be a big table that'll have all these sizes, and it'll have CFMs, and it'll have pressure. And it'll say this size at this CFM has this static pressure drop. And you want to pick something that's about 0.03 or less than that. Like if you didn't change anything, they would all be the same size,
Yeah.
if I recall. Yeah. So that's just, so someone has to check that. Yeah. Someone
Okay.
has to make sure those are correct. Yeah.
Great.
Yeah.
Which, by the way, I don't do now for my audience. I will not do because we're installing variable speed pieces of equipment. And whatever you size it for, the velocity is going to be wrong like 90% of the time,
Yeah.
in my opinion. How do you feel about that?
Yeah, variable speed equipment is great in a lot of ways, but it's really kind of making us rethink a lot of the manual D stuff. And I said ducts can be big, and that's fine. You'll still get the same amount of airflow. But when you start talking about velocity, we're not talking about velocity in the ducts. We're talking about velocity out of the register. That's what mixes there. I push mixing really, really hard in all my design classes. Like for example, one of the most controversial topics is where in a ceiling to put a supply register. You want to see people yell at each other. Have a classroom and start having talk about that. My grandpa told me to put it over here, and well, that's stupid. You got to put it over here. People get really upset about it. But my general rule of thumb is blow the air the opposite direction that it wants to go. Okay, so like if you're blowing air into a room, where does it want to go? It wants to go out the door. So put the register by the door, blowing into the room so that the air coming out has to collide with that air and it mixes, because the sooner you get the air to mix, the less likely there's going to be temperature variations that cause stratification, right? What causes stratification is temperature differences. But as soon as you can get that air to mix, it's going to stop stratifying. It's going to be all even temperature. Um, and then, you know, the type of register you use and all those other things. But the problem with variable speed is when they throttle down, they throttle down the airflow. And so when people are having problems with that, what I suggest is see if there's a setting that will leave the airflow on high speed, but throttle down the compressor, throttle down the condenser. So the airflow is not changing, but the temperature of the air is changing. Because if you throttle down the airflow, I call it bubbling. Instead of shooting out of the register, the air just kind of burbles and bubbles out of the register, and you don't get mixing. And then that cold air is just going to fall right to the ground, and nobody's going to be happy with that. So yeah, you got to have that velocity coming out. And so, you know, maybe if I start doing a lot more variable speed system and they have to vary the airflow, I might suggest smaller registers, you know, so they're not operating, they're not assuming always high speed, but kind of maybe a little less than high speed
Yeah.
to get better mixing. So
I actually just ordered these little plastic things that I've actually saved buildings, like multifamily buildings before, from themselves. They're like little things that you screw onto the light switch and it keeps the light switch from being turned off. So I've got them on all my fans in the house now, so my kids can't go around and turn off all my ceiling fans, because like the fans being on low speed all the time is totally integral to the way my house works. It
yes,
can't change that.
ceiling fans are highly underrated tools for comfort. Yeah, they really are.
Yep. And they look nice. For those of you who are like, I hate ceiling fans, think about the room full of people who are like, my grandpa said, like, just know that that's the same thing. It's cool, Russ. So as far as the DIY load calc software and also Kwik model, how do you see not pissing off professionals and saying Russ is trying to teach all my clients to do it themselves, and also help clients in places where they can't find anybody to do a load calc? Like, how are you putting that together in your mind?
Yeah, so I've been trying to get contractors to do load calcs for at least 20 years. You know, I've been training them and all this other stuff,
So
and
you warned them.
I warned him. I warned him. You know, I ran the PG&E had a free manual JS&D training in California for many years. And this was back. This was a long time ago. This was before PowerPoint. You remember transparencies where you had to put a transparency on overhead projector? I'm talking that long ago. I was training contractors. It was a 3-day class. The contractor will walk in the door and we'd give them a hard copy of Manual J, Manual S, and Manual D when they walk
That's
in the door.
expensive. Holy
That's like
crap.
$300 worth of books right there. And so they'd come in, you know, and they'd sit down through the training. The next day, several people wouldn't show up. And then the next day, more people wouldn't show up. Friday, you know, there'd be half the class would be left. And they'd go, you know, Russ is a great class. We really enjoyed it, but there's no way in heck we're going to do this. It's too complicated. It's too much time. Nobody's paying us to do this. The software is expensive. It's hard to learn, blah, 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 blah. You know, so all this stuff. And I got really frustrated with that. I got angry and I wrote a blog article in 2013 that said why we need a more simplified HVAC design methodology. And that pissed off some people. So everyone thought, oh, you're just talking about rules of thumb. You want to simplify the process and blah, blah, blah. And I would, no, I think the software needs to be improved. It was mostly a rant about the software back then. And so nothing really happened. Nothing really improved. The software didn't change. And then I had the opportunity when my son graduated from college with a computer science degree, I had the opportunity to put my money where my mouth is. And I I wrote a software program. Okay. And then I thought, okay, if I write this really awesome, really fun to use software, all the contractors are going to start doing load calculations. No, not going to happen. It's been a painful um, trudge to try to get contractors to do it. No matter how easy you make the software, there's still going to be a large percent of contractors that are just lazy or ignorant or unethical or not computer savvy. They just simply don't want to do load calculations, and that's
And
a high percent.
also, yeah, and also, in fairness to HVAC contractors, like the reason that they show up at your house with their shirt untucked is because they do not have time to tuck in their shirt.
Sure.
That's why.
Yeah.
So like
Yeah.
I
Yeah.
find that they're overworked. They're in horrible place. You know, it's like you can't make a computer guy who wants to sit in front of a computer for 6 hours doing a really detailed load, and design calc. He's not going to be the same guy who's going to go into a crawl space and spend all day trying to fix stuff. Like that can't be the same person. They want different things. So anyway, like life is hard, but yes, you're right. The design does need to happen.
So I've come up with this I call it the three-pronged approach to try to get contractors to do it. The first prong is the way we've been doing it. write a good piece of software, train contractors, and the ones who want to do it will do it. Okay. But that's a very small percent. All right. And then there's contractors who want to do it, but they don't have time to do it. Let's provide them a service. Let's do it for them for cheaper than their time is worth. Okay. That's the second prong. The third prong is for the contractors who don't want to do it. Let's go right to the homeowner. Let's have the homeowner do it. They're the ones who are most impacted by this thing. And if their contractors aren't going to do it, by gosh, let's teach the homeowner how to do it. Okay. Now the question is, can we teach a homeowner how to do load calculations? And it's a little misleading to call it DIY load calcs because the homeowner's not actually doing the load calcs. We're doing it for them, but they're collecting all the information. And what has really changed over the last few years is technology. So we have a better software. Kwik Model, I think, is a better software. And now we have the technology that can capture the house and create a floor plan for you. And Cubicasa is the one that we use. It's a phone app, and the homeowner, it's so easy, a homeowner can do it. They can scan their house, they send the file off. The next day, they get a floor plan of the house that looks like an architect drew it. That's all we need to do a load calc. They do have to measure the windows. Cubicasa will show the width of the windows, but not the height. So we ask the homeowner to measure the windows and tell us if there's any vaulted ceilings and stuff like that. So now what has really changed is the ability to do a load calculation on a house without actually visiting the house. The
Mm.
homeowner has the ability to collect all the important information that we need. And then there's things like infiltration. Well, is a homeowner going to do a blower door test? No. So we're going to assume average on the thing, and then we're going to run the loads with semi-loose and semi-tight, and we're going to show how big of an impact that makes on the load calculations. So we're going to say, here's your load calc, assuming your house is average. If your house is not average, it's going to go up by this much. If your house is better than what we assumed, it's going to go down by this much. And oh, by the way, if it's what we assumed, you can always make your house better. You can do things, and here's what you can do. Now it puts them in that mindset that, oh, we have control over our loads. It's not cast in stone. We can change the loads. What can I do to change my loads? Oh, I can tighten the house. Oh, I can add ceiling insulation, things like that. Oh, I can close my drapes on a hot day.
Mm.
And so it now it starts educating the homeowner too. And I think that's a really important aspect of the whole thing. And so basically, the homeowner collects all the information. They send it to us. We put it all into Kwik Model for them. And then we send them back a report that's got a bunch of educational material. And here's the key. We send them back the Kwik Model file so that if they find a contractor who uses Kwik Model, the contractor can open the file, tweak the loads if they want to. If they find we don't have something just right, or maybe the infiltration was off, and they can do the manual load calc or duct design on the house too. So that's the other big thing. So we're not assuming, oh, we're doing the load calcs and they're what they are. Here's the file, tweak them if you need to.
Yeah,
So
absolutely. And the reason that the duct design would be extra work for the homeowner, they're probably not qualified to do that. And are you really going to replace the ducts in an older house anyway? I think that that's your point, is that like somebody's been replacing windows, adding insulation, making this place more airtight with more weather stripping and all this stuff over the years, the last 20 years. Let's find out where we're at right now and then do that instead of just a simple take a 4-ton out, put a 4-ton back in.
right. But what you can do is evaluate the existing duct system and determine whether or not it needs to be changed, by using the manual D part of Kwik Model. So the contractor can just throw in some airflows and say, okay, I need this much airflow in this room. What size duct do they have? Oh, okay, that's good. Especially if you're downsizing equipment, sometimes you downsize the equipment and now the ducts will actually match the equipment because they were undersized for the big equipment. Now they might be better sized for the smaller equipment. And the opportunity to downsize equipment that's out there right now is just, it's unbelievable what low hanging fruit there is out there that contractors are just refusing to pick because they just don't want to do load calcs, and they're afraid to,
Sure.
it's a tough sell. It really
Fear
is.
is real, man. Fear is very powerful motivator. So
Yeah.
thank you very much for all the work that you do to take away the fear for everybody, pros and homeowners alike. Thank you very much for talking with me today, Russ, too.
Pleasure. My pleasure.
Awesome. Okay, you can find Russ King at Kwik Model and also at DIYLoadCalcs.com. You have been listening to the Building Performance Podcast. I hope that you will comment if you have anything else to say. Tune in next time.